Let's get started. So today we're going to be going over variables and getting into some conditional logic as well. So we talked about variables yesterday, I believe. Somebody brought up a point. I should have pulled in this example. There was some code given the other day where we had an example of creating a variable like x equals 3, and then we had something like x plus equals 1, and if we print x, we're going to get 4 because this this sort of recompiles as x equals x plus 1. So I wanted to touch on this because I actually forgot to mention it. This syntax and this syntax here require x to have a value. So this modifies x if it already exists. And I forgot to mention this yesterday. So if I, and I'll see people do this occasionally where they'll try to declare a variable, which means to bring it into existence. So up here is an example of a valid declaration of a variable. We're declaring x as equal to 3. This is not a declaration. It's an assignment to an already declared variable, right? So in this one, we declare the variable and assign a value to it, which we need to do to declare it. In this one, we modify an existing value, right? So this code here is not going to work. Somebody asked a question that was kind of pointed at this yesterday after class, and I wanted to bring this up because it was a good point, and I wanted to mention it because it's an easy enough mistake to make. So notice with this one, we get a name error. It says name x is not defined. And let's just put, I'm just going to do this. Oh, sorry. Okay, so I'm just making this little, I'm using single line and multi-line switches or comments to make a little switch so I can turn on and off this block of code. And then this line of comments here is just to give me a visual separator so I can see where that switch begins and ends. So I can turn on and off multiple lines of code by commenting out this top line. Just so we can see what's going on there. Let's just do this really quick. Just duplicate that, and we'll do that. And we'll say this. Okay. Okay. There we go. I'm just trying to clean this up because I am going to publish these notes to our GitHub repo. So we can say this is invalid and the other one is valid. Good. We get a few of these comment sections just so we can have something to work out of. Whoops, dang it, I deleted my original one. Excuse me. Okay, now we can get moving. Apologies. Okay, so that's a good point that's worth mentioning for variables. So variables are, in general, they're just useful for capturing a value of some operation so you can use it later. Sometimes that can be helpful for like breaking things out into like small steps. You know, you can do an operation and save it into a variable and then use that variable value in something else. Make your code feel less complicated. And sometimes you need to use something in multiple places and you want to capture it and then use it in multiple places. So all kinds of good uses for variables. Oops. Okay. Yeah, and this is just saying something similar. You can think about a variable assignment as giving a name to something that can be accessed later by different parts of your program. You can use a variable to store any type of data, so any data type, and they're useful for reusing parts of your data. Yeah. Okay. So declaring a variable, it's worth saying explicitly now. Earlier, you saw me give examples when I was talking about Booleans. Booleans are a simple type. They're just true and false. They only have those two values, but they're very important. And working with them, understanding what kind of operations get evaluated as Booleans. And I gave an example of this, right? So Booleans just true or false, right? I gave an example of some operations that evaluate to true or false. And one of them is equal. So is 3 equal to 5? Print 3 equals 5. This is false, right? So notice how I use two equals signs. And the way we say this is 3 equals 5. Is 3 equal 5, right? When you're assigning a variable, you use a single equals. And this is why we don't use a single equals here. So if I say A equals 3 and B equals 5, really I should be saying, and I'm guilty of not saying this in the correct way, but what I should be saying is A gets 3 and B gets 5. In this context, that's what I mean, but my habit is to say A equals 5 and B equals 5 because I'm used to just seeing that as the equal operator. But really, this is not a question of equality whether B is equal to 5. This is an assignment of the value 5 to the name B. So it's a very different operation. So I just wanted to bring this up, and I know I touched on this earlier, but it's important it's worth it to make this a deliberate distinction in your mind now before it gets out of hand, or before it causes you problems. And it may yet cause you problems. You may mix them up. You might try to check equality across something and say, is 3 equal to 5 in this way? Let's just look at that. This will be an error because we can't assign the value 5 to the value 3. Like, what would that even mean? So a syntax error, it says an expression cannot contain an assignment. Perhaps you meant double equals, and it gives you this example. So it knows this is a common mistake. So there you go. So you can assign, you can also assign more than one variable on the same line. So if I wanted to do, let's say A, B, C equals 11, 22, 33, 44, B, C, D, whatever, so I can, if I want to assign 4 variables on the same line, I can do that, but I just have to have a value for each of them. like this. So this can be useful if you want to just kind of condense your code a little bit. You don't have to go hog wild with trying to get everything onto as few lines as possible. But this can be nice if you have, a couple simple variables and you just want to make them on one line real quick. This can save you a little bit of room. It's less important that you use this particular thing in your coding, and more important that you know that it's possible because you will see it. So if you see code that uses this A, B, C sort of pattern, right? And these could have names. I'll corn, I don't know. These could have other names and have other values associated with them. But if you see this kind of pattern, now you can recognize it for what it is, but it's less important that you utilize this pattern in your own coding, because it's exactly the same as saying A equals 11, B equals 22, and C, what am I doing? C equals 33. So those are exactly the same. I just, the other day on Twitter, I saw I follow like a lot of technology and programming accounts and people who post a lot about programming and stuff. And there's this like perennial meme that pops up, I think probably since the days of Fortran. I assume people have been saying this for as long as people have been programming, that variable naming is like the hardest part of programming. And that shouldn't make variable naming sound really hard. It should be taken as, once you get into the swing of things with a programming language, variable naming becomes the hardest challenge. And I see people, it's important to give good names to your variables. You don't want to necessarily overthink things, but I mean, to me, I want to think of a name that gives me a description quickly. And one of the reasons it can be hard is you're in the middle of solving a problem and you've got this algorithm in your head and you're thinking through it and you're doing like big brain stuff, and then you're like, oh, I gotta name this thing. What do I call it? What on earth do I call this thing? And you don't want to stick on it too long. Just give it a name, but it also has to be something that reminds you what it is. So when I'm thinking of a name for something, I will usually consider its type. So if I have a list, for example, often I will just call a list LST. This is like an easy go-to. If it's a list of animals, I might call it animals list, right? A lot of people would just call this animals and just know, well, since it's plural, then it must be a collection and it's probably a list. Animal might not be a good name for a collection of animals, right? This doesn't tell you, calling it animal singular doesn't tell you that it's a collection of multiple animals. So my preference is to often just include some note on the type, or something akin to the type. So I might call this animals LST. And I always use LST as a shorthand in variable naming. If I call it LIST, you might be like, well, I'm going to actually spell it right. This is, that's nice. However, you've just overwritten the list built-in keyword in Python and saved a value to it. So list is a keyword that's built into Python. It's actually a function as well. So if you save a value to it like this, you're actually going to overwrite the function, which will cause problems in your program. Now, just to put your minds at ease, you won't overwrite it like permanently and destroy your Python install. You'll just make something of the same name that will have priority while your function is running, or while your program is running, and that's not a good practice. At best, that's not a good practice. At worst, it's gonna mean you need that function and you don't have access to it. So it's important to remember that while you're naming variables, and to give variables names that don't conflict with the built-in words in Python. Like I probably don't want to call something print, because then I can't print anything. Remember, you know how much I love print, right? Print is gone. No more print. Or it's not gone, it's just it's a list. So this says type list is not callable. So it sees me trying to call this function, which means invoke it to use it. It sees me trying to use that function, and it's like, well, print is a list, so I can't use it that way. So that's something to bear in mind. So yeah, variable naming can be a little challenging. I think giving it some thought, sitting down and like thinking about what it means for a variable to have a good name, and some things that you can do to help give you a sense of, to help name a variable in a way to give you a sense of what it is, right? So, you know, if I have a number, I might call it num or number, or I might actually give it a name relevant to what it is that I'm counting, or what it is that number represents. So yeah. So there are variable naming and casing conventions for various things in Python. So what casing means is like how you delimit or separate words from each other. So let's just go back to the animals list example. Notice I separated the words with an underscore. There's a lot of decisions you can make about how to do this, and it's entirely subjective. You could just jam them together like this, although this doesn't really, this is kind of confusing. It's not clear where one word ends and the other one begins. There's Pascal casing, or this is camel casing. Then there's Pascal casing like this. There's kebab casing, which Python does not support. And then there's snake casing, which is underscore separation of words. So when you separate, if your variable has multiple words in the name of it, that's fine. Just separate the words with an underscore. And that's, you don't have to do it that way. You know, you could use a different naming convention, but it's nice to keep code standardized so that the way that I write, you know, at least in this particular way, the way that I write my code is going to be legible and intelligible the way you write your code, you know. So there will be some parity there. So it's kind of a coding style thing, but and I know I've kind of put emphasis on that being very subjective, and it is. But in this particular case, I would say this is, even though technically it's a stylistic thing, using snake casing is sort of a bigger deal than a lot of things. So I highly recommend that you use snake casing. Okay, cool. And here is, let's actually just go to this really quick. There's some reserved words. I'm going to just paste a link in Slack to this. There's some reserved words that you can't use. As variable names. Cool. Booleans. Okay, so this is going to lay the foundation for our next step. So pretty soon we're going to be getting into writing conditional logic. So we've already covered some basic data types. Just a quick review here. We've talked about integers, floating point numbers, Booleans, which we're going to talk about more. And this is going to open the gateway into conditional logic, and strings. We're going to be, we've also talked about using these with variables, right? Saving the results of these operations and data types into variables to use them later. So we're going to talk about writing code that executes under certain conditions. And if you think about it, a condition, if you can think about what a condition is, you know, if you have instructions to do something, and in those instructions, there's a condition that changes how you do it, right? So a condition is something that's true or false. And this, I hope this is an intuitive concept. I hope to frame it that way. So, you know, maybe you go to the grocery store and you're going to get, you're going to buy kale, and you might say, so under the condition that the grocery store doesn't have kale, you're going to buy lettuce, right? So if it's true that the grocery store has kale, then you buy kale. If it's false that the grocery store has kale, then you buy lettuce or something. I don't know. So that's an example of a condition. You can think about conditions as being true or false. Maybe you can think of an exception to that in like day-to-day life, but in Python, you can just think about them as true or false. So let's look at some ways of working with Booleans. And we went over this a bit. We talked about some of the Boolean operations. Greater than or equal to, less than or equal to, and not equal to. Right, so if we do, let's just do something easy here, like 5 and 5. Cool. Nothing's going to happen because they're not printing it out. Right. So 5 is greater than 5 is false. 5 is not greater than 5. It's equal to 5. 5 is greater than or equal to 5 is true. 5 is equal to 5, and that's encompassed in the greater than or equal to. 5 is less than 5 is also false. 5 is not less than 5. It's equal to 5. Less than or equal obviously is true. Equal is true. Not equal is false. So 5 not equals 5 is false, of course. Cool. So this is going to give you, so these are simple examples of conditions. We'll be looking more at these shortly. I think we touched on these as well. Not, and or. And I would encourage you to do this, to like write out the truth tables. Even doing it a few times can help solidify it. For some of you, I think this is probably going to just make sense and be clear. But for some of you, if you're just starting out, it can be helpful to kind of write out truth tables for these and kind of look at them. So, so not true. We went through this yesterday, but we'll go through it again. Print not true is going to be false. Not false is going to be true. True and true is true. And then we can say false. And then we'll do this for or. So we have not, and or. These are our three logical operations. So we'll say or, and then we can say true or true is true, false or true is true, true or false is true, false or false is false. Cool. So we can expand upon this a bit. If we do something, let's get a few numbers here. Let's say A, B, C, D equals 3, 5, 3, 7. So I could say print A less than B and C equals A. Why do I have commas here? I don't need commas. Okay, so this is more, kind of more like how you'd see it. I like to put the parentheses around the terms for the and. That way it's kind of clear that here's one term and some other term, and we're comparing these. When you see an and, both the left hand and the right hand, an and an or, the left and right hand operands in that expression need to be Booleans, right? So is A less than B going to give me a Boolean? Yes, because I'm doing a comparison, right? So basically the way I can tell is, does it use one of these operators? And there's not that many of them, just less than, greater than, equal to, not equal to, basically. So there's just a few Boolean operators. So when I see an and, I'm just making sure that that we have a Boolean on the left and the right. And the reason I'm saying that is if I have like A plus B, that's going to give me an integer. I believe this will actually work, but it's not quite as clear why it works. And we'll get into why that works later. But really, you sort of want to do this with the assurance that you have a Boolean on both sides, or at least a strong awareness of the types on both sides. Okay. So you can think about this. We can treat this as a little breakout. Is this going to print true or false? Oops. Cool. Yep. Yeah. So we can look at these two expressions. A less than B. A is 3. B is 5. A less than B. 3 less than 5 is true. And C equals A. A is 3. C is 3. 3 is equal to 3. So that's true as well. So we have true on the left, true on the right. Remember, true and true is true. So this is going to give us true back. Two-ray, that's okay. I can't. You're probably gonna see me misspell true as well. You know what? Just for solidarity, two-ray. There we go. Cool. Okay, let's do this breakout. let's see. I'll just post this right here like this. You can see it. Cool. All right, let's print this off. True. Cool. Looks like y'all got that pretty good. Okay, Bitwise operators. These are less important, but I'm going to say if you already know what Bitwise operators are, well, here you go. Here they are in Python. We're not really going to cover these, but so the tilde is the Bitwise operator for Bitwise not. Ampersand is Bitwise and. Pipe or vertical bar is Bitwise or. Yeah, like I said, yeah, don't worry about these for now. If you're coming from another language, or if you have experience where you know what these are, here they are. If not, then don't worry about them. Same thing with exclusive or, which is the caret symbol. This one actually can come in handy, I would say. So let's look at our OR table, right? Like our OR table is, well, yeah, let's just pull this up again. Our OR table gives back true if any of its operands are true, right? So if they're both true or one of the other is true, the only time OR gives back false is if both of its operands are false. There's something called an exclusive OR, which means that it's only going to give back true if one and only one of its arguments are true, right? So it's like asking if these two things are different. So let's do this. If you're familiar with formal logic, this is often called XOR. I'll do it, XOR. Or, so XOR is going to be, oh, let's do this. Caret, true and true is false. Whoops, and I just realized you can have these in a weird order. Let me go change those. This is just trivial, but it bothers me nonetheless. Okay, there we go. Cool. So basically, I don't know if that's right to say the only, but the big difference is, let's do this. Whoops. Right here, and drawing in my text editor is a little slow. Excuse me. Okay. So where the arrows are pointing are the where these two are different. So that can be useful. Like I said, these are kind of like if these two things are different. Honestly, you can also use I think in most settings you can also use not equal, and it's kind of the same thing. Cool. So order of operations for logical operations are the bitwise operators, which are going to be, looks like they left out or here. I imagine this was meant to be or in that sort of void there. So not, bitwise not, bitwise and, bitwise XOR, bitwise or, and then Boolean not, Boolean and Boolean or. To be clear, the things to take away from this are really the Boolean not and or. Okay, cool. Let's do these. I'm going to paste them into Slack. Excuse me, let me actually, sorry about that. There we go. It's always nice to have it nice and formatted. I'll delete the prior message. Cool. I'm seeing a lot of answers in here. We're not quite through the time. If you don't have an answer in, go ahead and put one in if you're just finishing it up. But we'll go back. We can wrap that one up there, I think. So yeah, let's look at the solution for this real quick. Okay, so not 7 greater than 2. So 7 greater than 2 is true, not true is false. So that's going to give us false. Um, 3 greater than or equal to 2. 3 is greater than 2, so that's true. That we have an or here, so we've already determined this is true. We don't even need to check this second condition, so that's true since we have an or. But 5 is less than 1 is false, so we have a true or false, which is true. Not 8 is false. Now this is a weird one. I thought this would end up coming up later, but it looks like we're gonna talk about it now, which is fine, I guess. I mentioned this briefly earlier, but yeah, Python, if it sees something that's not a Boolean, it can kind of treat it as a Boolean. So there are different rules for each of the types, but they're pretty simple. So values equal to 0, so 0 and 0.0 are false. Any other numeric value is true, right? Even if you have a float that's 0.0003 or something, it's close to 0, but as long as you're not getting an underflow, then it's going to be true, right? Even a negative number is also going to be true. So with strings and any other type that's sort of a collection of things, so strings are a collection of characters, if it's empty, it's considered false. If there's anything in it, even if it's one thing or whatever, then it's going to be considered true, right? So we have bool of an empty string. So if we cast this Boolean of an empty string to a Boolean, it's going to be false. And since we have an and here, we already have a false, so we know we're going to get false, right? But 5 not equal 3 is true. So in this case, we have a false and true, which is false. And it looks like we have the same thing here. So yeah, cool. Hopefully that helps. All right, control flow. Yeah, this diagram I think makes it seem more complicated than it is almost. But basically, we have our program, and encounters a condition, and it takes one path if the condition is true. If the condition is true, it executes the conditional code, sometimes called the consequent or the body of the condition, or the body of the if. So it's going to run that code, and then it's going to rejoin the regular flow of the program, or it's going to take some other path if the condition is false. So let's look at this. So Python has conditional keywords. It has 3 conditional keywords. Let's look at one at a time. So we can start a condition with if. So we can say if, then some condition. Remember, a condition is any expression that evaluates to true or false. So we could say if A greater than B, and let's give A and B some values. So A equals 5 and B equals 10. Oops. So we say if A greater than B, then we want to print A is greater than B. So if I run my code, what's going to happen? Nothing, right? So I asked to print A is greater than B if A is greater than B. And A is 5, B is 10, so A is less than B. So A greater than B is false. So notice if the condition is false, the body of the if block does not execute. So this code is not run at all. I might want to print something like if A is not greater than B, maybe I want to print B is greater than A, right? So you might think, okay, well, I guess I'll just put this down here. And it says B is greater than A, right? The problem is, what if A is greater than B? Well, now it says A is greater than B and B is greater than A. Well, obviously that can't be the case. One can be greater or less than, or they can also be equal, but they can't both be greater than each other unless we're talking about some dimension of reality that we're not talking about. So one thing you could do is just throw this in another condition. You could say if B greater than A. That's one thing you could do. If you look at this, this isn't actually, I was going to say it's a perfect complement. It's not quite. One of these would have to include equality, right? So let's say if A is, yeah, let's actually handle that differently real quick. So you could make a second condition here. The thing, and something that might be better in this scenario is to use the keyword else. Okay, so else else holds the code that executes if the condition was false, right? So we have if, then some condition, then the code to execute if that condition gave us true, and then else, and then this gives us the code that execute if that condition was false. So if A is greater than B, we print A is greater than B. Let's make A 5 again. So in this case, now it's false, right? That A is greater than B is false. So we'll run this code when the condition is false. And this brings me to my other point. What if they're equal, right? If they're equal, this is going to say B is greater than A because A is not greater than B. 10 is not greater than 10. It's equal to 10. I could include equality here, but then I just have a different version of the same problem. It's still not going to tell me what I want to see. What I really want to see is some other condition here, which is A and B are equal, right? That's what I really want to see. So what I can do is I can say elif. It's like saying else if, right? There's another keyword called elif, E-L-I-F, and what it's saying is E-L-I-F, elif, else, given that this prior condition was false, else, if, and then we have some other condition to check. If A equals B, print A and B are equal, right? So elif will execute code only, well, it'll check this condition only if the prior condition was false. And it'll execute the body of this elif only if this condition is true, right? So this is how you can chain conditions together. So there are no sort of simple rules of thumb around how to do this. Conditional logic, like, you know, the rules, it's like simple to state the rules, but you have to think through every problem, because there's times when you want to have multiple consecutive ifs, right? If two things can both be true, right? In this case, only one of these things can be true, which means I want only one of these conditions to execute. So chaining them together in this way with an elif says, okay, if the previous one was false, then check this one. And then an else says, if all of the other two were false, right, then run this code. There are certain other problems where you might want consecutive ifs, like if A, let's see, A equals C. Let's have a C in here too. And print A, well, we'll just do this. A and C are equal. And if A equals B. Oops. Right, so there are certain scenarios. It's possible that A can equal C and B, but it's not possible that A can equal B and be greater than B, right? So A's relationship to B can only have one of three possible states, whereas it can have a relationship to B and a relationship to C, and those, you know, both of those things can be true at the same time, right? So you have to think through whatever problem that you're doing. You may need a single solitary if. I say this because I see a lot of people that'll say, well, I've heard people say a lot that they think that every if should be followed by an else. And there are philosophies of programming that use this, but it's not something that I want. If you're studying for the TI, if you're new to coding, this is not something that I want you to think about for now, right? I would much rather have you think about each problem needs to be thought through in its own way. It's easy to jump to want to jump to like having rules of thumb about this, like every if should have an elif or an else behind it. That's not the case. Sometimes you need a single solitary if, sometimes you need consecutive ifs, sometimes you need an if else, sometimes you need an if elif else. To be clear, else always ends a chain of conditions, right? We can't have an elif after this else. I mean, what's that even saying, right? So else if the, elif some condition, else what is this an else to? If the prior else was false, this else can't be false. It's necessarily a catch-all that says, if given that all of the prior conditions, in this conditional chain between the if that started the chain, if all of those are false, then it'll finally run the else. So, yeah, the rules can seem simple, but I think the easiest thing to do is to just remember that each problem requires thinking it out thoroughly, basically. All right. Can I provide an example that has two if requirements in order to execute? You mean like consecutive ifs? Oh, if this and if that. Two conditions. Yeah. Let's look at this. This is getting into like more complex conditions, right? So we could say if A equals, let's say if A equals B and A equals C, then we know that B and C are equal. This is one of those, oh gosh, this is one of those rules of logic. I didn't even mean to do that. And I can't remember the name of this rule. It has a name, right? If two things are equal to a third thing, that they are equal to each other. In other words, if A equals B and A equals C, then B and C are also equal. So, but this would be an example of how to express that in Python. Of course, we could also just check if B equals C, but whatever. Hopefully that helps. We got a question, is there a limit on the number of Elifs? Nope, not at all. You can fill in the middle with as many Elifs as you like, or as you need. Yeah, so doing this with one line of code, you could do this with a nested if, which brings me to another point. There's certain problems. Well, yeah, so you can put an if inside of another if, right? So if I say if A equals B, if A equals C, let's do this. B and C are equal, print A equals B, to B, to be or not to be. Who notices something weird about my code? The spacing, the spacing might look weird. Well, it definitely looks weird because of this, because of line 117 here. I want you to train your eyes for this, though. I want you to train your eyes to look at your syntax highlighting. Get used to the way your whatever your environment highlights valid syntax. Notice how this if is purple, this if is white, this if is blue, right? Like it's all over the place. That should not be the case. You shouldn't have inconsistent highlighting. This means that the parser is confused and not behaving correctly, which is useful. It's useful to see this bad syntax highlighting because it tells me that my code is off, right? So I sort of absent-mindedly pulled this line out of here. If I run this code, we're sort of taking a little bit of a detour from talking about ifs, but I wanted to point this out. Keep an eye out for your syntax highlighting. If it's off, if it looks a little funky, you might have an error. So this is an indentation error. It says expected an indented block. And it points at the line that it thinks you meant to indent, not the line that caused the need for the indentation, which was 115. So notice that when I supply a body for this if, when I want to put code in the if to execute if the condition was true, that I indent it, right? And I've talked a lot about coding style, and you might think, oh, well, that seems like a good practice. It happens that it's mandatory in Python. So in Python, white space is syntactically significant. So the white space before this line 116 in this case, is syntactically meaningful to Python, right? So I have to, and there are several other things that are like this. Loops and functions require something to be indented in them. If I create a condition like this, I have to put something inside of it that is tabbed in, right? So this, for example, is not inside this if. And the reason is, how would I know when the if ended? If this was valid, how could I tell that I was no longer inside of this if, right? And that I wanted to go back to, my regular code, right? So other languages will use like curly brackets like this. And if you want to do like this kind of formatting, you could. Python doesn't do that. Python uses white space. So you have to put something inside of it, and it has to be tabbed in. The convention here is to use 4 space characters. So I don't hit the space bar 4 times. What I do is I have my editor to set up that when I hit tab, and this is true on Replit, most good editors, I think VS Code will handle this by default. You don't even have to set it up, but you just hit the tab key and it'll put in 4 spaces, 4 regular spaces. So that's something to watch out for. Cool. Anyways, back to this other question. The question was that I have to do this on 2 lines. You can nest these conditions like this. This is valid. You can nest an if within an if within an if within an if as many times as you want. Although if you can avoid that, you should. So in this case, I can avoid this kind of nesting like this, and I can unnest them and take them onto 1 line like that. And that kind of makes the code a little cleaner. But notice in this case, I can say if A equals B, well, if A equals B, then I'll print A is equal to B. And then if A equals C, then I know that B is also equal to C. So I can say B and C are equal, right? So this way does technically give me an option that the more condensed way doesn't. So I have a little more flexibility with nesting ifs, but a lot cleaner code when I don't nest them. But again, every problem is unique and you have to solve it in the appropriate way. Okay, cool. So one last question. Could the if A equals B, okay, one thing I'm noticing you're saying if with capital IF, that's going to be an error all by itself if I do capital IF. And I'm sorry if that seems like picking a nit, but yeah, I guess I'm just going to pick that nit. Could the if A equals B and if A equals C, then be written A equals B equals C? I think it can. If A equals B equals C. Yeah. So this is sort of yet another variation on that. Actually, I should include this up there. A equals B equals C. So this would work for this particular case because we have this if A is equal to B and A is equal to C. You know, like I have something, you know, we have this relationship between these 3 things where this works. I would not say that you can always or even commonly translate an and where you have 2 conditions into 2 equality statements like this. The fact that this works happens to be unique to this specific scenario and will not be the case usually. Because you might have a scenario like if A equals B and hello equals tomato or something, right? Like you might check one set of things on one side that has nothing to do with the other set of things on the other side. And I would say this is maybe almost more common where, you know, the relationship between, you know, one condition and the other condition might be they might be kind of unrelated things, you know, but you want to say, okay, well, if this thing over here and this thing over here are both true, then I have something that I want to do. I have some body of code. By the way, let me get this out of the way now. Pass, what I was saying about needing to indent something and needing something to be there, like I literally have to put some code here. If you want to just put a placeholder in, Python has a keyword that whose really only job is to be a placeholder. It's called pass. It just means that like pass, don't worry about it. Just move on to the next thing. So I'm just going to put pass there because I can. Awesome. I don't worry about asking questions about ifs. I'm just going to say, like, if anybody else is feeling burdened by this, these are important questions. This is important to suss out. So if anybody else has questions, don't hesitate to ask. I don't mind spending extra time on this. This is one of those things that, like, it just happens that it brings up a lot of questions. What about this? What about that? What about this? Yeah, feel free. I don't mind giving examples about this because even though control flow is kind of simple, there's sort of a simplicity to it. There's enough going on that, and it's important. You know, it's hard to write meaningful code without having a strong understanding of being able to implement conditions, right? So yeah, it's important enough that it's worth spending some extra time on. So no worries, y'all. Is it better to use pass than to use comments? Let's look at it. Let's check it out. So better. So let's look at something real quick. So if I comment this and I say placeholder, placeholder. Oh, why do I feel like I misspelled that? I think that's right. If I do this, I'm actually going to get an unexpected EOF, right? So this is still the error that I would get if there was nothing in here. Right, so a single line comment won't do anything. Remember when I talked about strings? You can delimit a string with single tick quotes or double tick quotes. And then when I said before that, when I was talking about multi-line comments, and I said you can make a multi-line comment with 3 single tick quotes or 3 triple tick quotes. Well, as it happens, multi-line comments are Python strings. Single line comments are not. Single line comments are just comments. They represent no valid data type in Python. Multi-line comments are multi-line strings. So sometimes in function heads like def, let's say factorial, this is sort of the function that we've been giving an example of. You'll, instead of seeing a pass, sometimes you'll see a doc string. And it'll be like factorial returns the product of multiplying, the product of every number between 1 and n, including n. Its input is going to be n, which is an integer. The number to take the factorial of, and it returns a prod, which is an int, the factorial of n, right? So this is, admittedly, this is a little bit sloppy. This is just a quick and dirty doc string, but this would be a doc string for factorial. And this will act as a placeholder. So you can use a multi-line comment. You can also, I believe you can also just use a string. You could do this. You could just say like placeholder in quotes. I think that'll work. Yeah, so this ran without error. So you could just throw a string in there or something. But then you're going to sit there and you're going to think, what should I name this string? But if you have to think about it at all, you should just say pass. Because Python just knows, oh, this is valid code that just doesn't do anything. So you will see us use pass. I would say that if you're going to use pass as a placeholder, either for something that you're going to come back to later or whatever, just temporarily, whatever. I would say the best way to just hold that place is with pass, but not necessarily in the sense that it runs better or it's more efficient, just in the sense that it's convention and it's clear that you're like, I'm just using this as a placeholder. I'll come back to it later. Excuse me, I got the hiccups, which is great. Cool, all right. Let's move it forward. Actually, we're a little past the halfway point. Let's reconvene at 20 after the hour. We'll have a little break. Go ahead and take a break, stretch your legs, grab some water. Sorry, folks. Okay, cool. I was worried it wasn't recording there for a second, but it looks like it's recording. Great. Cool. This is really the meat of tonight's class, if else. Yeah, feel free, bring any questions if anybody's got anything else, but for now, we can just move on to breakout. Actually, let me find this down in the markdown document here. Come on Slack. There we are. Oops. There you go, and I got 5 minutes on the clock. Okay, cool. Can wrap that up there. So I'm going to give you, I'm just going to go through this, give you a solution. I'll just kind of take this the way I would take a problem. Oops, actually, let me do this really quick. Okay, there we go. So write a code snippet that checks two numbers X and Y. So I'm not going to do this to show you how to do it as much, because I think I don't know if everybody got an answer in. If you didn't, that's fine. Feel free to put an answer in now if you want. And I think most people got an answer in here. But what I do want to showcase is sort of a workflow pattern here, right? So taking things in chunks. I'm not going to write this as a function, and functions are kind of a big part of like me showing workflow stuff. So, but this is sort of a little bit of a, give you a glance of like just the way I would approach some problem solving tactics. Okay, so first thing I'm going to do is just read through it and see if there's anything easy that I can get out of the way. I'm also, as I'm reading, I'm looking for, I'm always thinking about ways of testing if this is going to work. So I want to see if values are given that say, well, given these starting values, this is what we should see for those ending, this is what we should end up with. And if I don't see that, I want to be able to sort of scaffold that and infer what that should be. So that way I can verify that my code is working as intended. So write a snippet of code that checks two numbers, X and Y. Okay, so like I said, I'm looking for easy things that I can get out of the way soon, and I'm looking for tests, right? So X and Y. Doesn't say what they're going to be. I'll just make them 7. No, 6. Okay. I don't know why I'm so invested in that. Okay. Checks if the sum of the two numbers is greater than both numbers. If that's true, print both numbers are positive. So I'm also going to say, I'm also just going to kind of take liberties to rewrite this, because this seems like this could be written more clearly, and this is my text editor, so if I want to butcher this text, I'm free to do so. Write it as clearly as you want. So I'm going to say, if the sum of the two numbers is greater than both numbers, print. I'm almost just turning this into Python code at this point, sort of pseudocode. Probably do the same to this one. If the sum is equal to either number, print at least one number is 0. Otherwise, a synonym for otherwise is else. This is another thing. When you're reading a problem statement or when you're thinking through code, you sort of learn to translate words that you commonly use that in your day-to-day speech into code, right? So if you hear yourself say otherwise, or if the problem says otherwise, you can probably always translate that into an else. I don't know of a scenario where that wouldn't work, but if you can't, it's at least common enough that you can consider it, right? Okay, so otherwise, if those other two things weren't true, then we're going to print at least one number is negative. Okay, so I lied. I think I am going to do this as a function. We haven't talked about functions yet, but we'll get into this. So I'm just going to call this compare numbers. We're going to take in, I'm going to call it A and B actually here. So we'll have A and B. And the reason I'm doing this is so that I can make multiple tests. So since we have conditional logic here, I want to think about this as, I want to think about testing this in a way that will execute each of these channels, right? So you can think about your code taking certain channels, like channels in a river. So I want to make sure that I can get each of these conditions to trip and print out the appropriate response. So The way I can do that, let's have a pass here for now. The way I can do that is by calling my function multiple times. So what are we looking for here? We have 6 and let's say -3. And then I think we had something with 0. Okay, so if the sum of the two numbers is greater than both numbers, print both numbers are positive. If the sum is equal to either number, print at least one number is 0. Otherwise, print at least one number is negative. Okay, cool. So we need a scenario where both numbers are positive, at least one number is 0. Let's say both numbers are 0, and at least one number is negative. So I'll just annotate these. Positive, 1, negative, 1, 0. Two zeros. Okay. And then let's also do 2 negatives while we're here. This is a nice thing about this. I'm now taking an exhaustive approach. Okay. So now for each of these, I want to determine what my result should be. So for this, and this is pretty simple, so I'm just going to put a comment after here and talk about what I expect. Both numbers are positive. Let's do our zeros. We'll do this and this. At least one number is 0. And at least one number is negative. Now, this is a pretty simple problem. Some of you might be thinking like it's a lot of almost as much effort as I've gone through just to set up, the testing of the problem as it would have been to just solve the problem. And honestly, yeah, as soon as I get this description here, I can just like copy paste this in and then turn this into valid Python code, which is what I'm going to do anyways. So what I hope to show is less about how to solve a problem this simple, because this is really overkill. I admit that this is overkill. Oops. Let's see. But more to show how this kind of technique will come in handy with problems that are not as simple, for sure. Okay, cool. So I have my prints in place. If the sum of the two numbers is greater than both numbers. So if x plus y is greater than x, let's do parentheses there, parentheses there. And we can say and x plus y greater than y. It's likely that you could make that simpler or more elegant, whatever. This is going to work. Who cares? Then let's say, if the sum is equal to either number. Okay, so actually I'm just going to copy this and copy that line. And we'll say if it's equal to x or equal to y. I'm going to say an Elif here because only one of these statements should print here. So we'll make it a conditional chain. We'll chain them together with if, elif, else. And then else is its own condition. So let's just look at the pattern I'm expecting here. So both numbers are positive. At least one number is negative, should get 2 of those. And then at least one number is 0, should get 2 of those. So if I see that output pattern, then I know passed all my tests and I'm good to go. Well, it's kind of throwing things off. Usually I write functions that return a value, so it's I'm used to printing them out, but in this case we're printing out inside the function, which is not generally the case. I screwed up. At least one number is 0. So we have an error. Look at that. So that's interesting. Oh, I know why. Because if the sum of the, you know what? I'm just going to say, I think this should be or, actually. Is that right? Am I crazy here? Okay. That's what it was. So positive, negative, negative, 0, 0. Okay. Cool. Yep. Yeah, y'all caught it before I did. Yeah, that's okay. All right. So stuff like that happens. And you will, like I think I said this at the beginning, you'll see me make mistakes in earnest, and I'm resigned to that. And I want you to, I mean, if you're new to programming, I think it can seem like a walled garden. You learn to manage, you learn to like catch errors quickly, but I don't know if it's really worth like holding yourself to the standard of like never getting errors or never having problems with your code. Like you're gonna have problems with your code. The skill that's worth learning is learning to catch those quickly. So cool. All right. Hashtag nailed it. All right, cool. We did this. Oh, I was like, okay, we did this breakout. There's the breakout solution. Cool. Well, we're done very early today. So here's the homework links. I feel bad for ending this early, but yeah, I think it's okay. Feel free. I'm going to stop the recording and then we can take questions.